Hello everyone, welcome back to logicbinder. In today's video, we shall discuss about context-free grammar and types of derivations. A context-free grammar is used to describe and define the syntax of programming language constructs. It specifies the rules that determine how valid strings or programs can be formed in a language. A CFG is denoted as G, defined by using 4-tuple notation G equal to VTPS, where V is finite set of non-terminals, T is finite set of terminals, P is finite set of production rules. Productions will be in this format: alpha goes to beta, where alpha is single non-terminal, and beta it can be combination of terminals and non-terminals. S is the start symbol and it belongs to one of the non-terminal. This is an example for context-free grammar to accept arithmetic expressions. The non-terminal symbols here are whatever the symbols you are writing on the left hand side of each production. Here we are using expression, term and factor. All this will come under non-terminals. Remaining all symbols will come under terminals: plus, minus, star, slash, open parenthesis, closing parenthesis, and ID. Remember, in context-free grammar, simply whatever the symbols you are having on the left hand side of the productions, all productions, those are considered as non-terminals, or you can call them as variables also. Remaining all symbols are considered as terminals. For example, the expression ID plus ID star ID. This can be generated using these production rules. Notice that multiplication has the higher precedence than addition because the grammar separates expressions into expression, term and factor. The factor represents the most basic unit such as identifier or an expression enclosed in parenthesis. The term handles multiplication and division operations. The expression handles addition, subtraction operations. This structure helps the compiler correctly understand and pass the arithmetic expressions. We can summarize the context-free grammar as a formal way of describing the syntax of a programming language. It consists of non-terminals, terminals, production rules, and a start symbol. Context-free grammars are widely used in compiler design to define programming language syntax and to build parsers that check the correctness of the program. For understanding the context-free grammar easily, generally we will use some conventions. First one is non-terminals. Non-terminals are represented by uppercase generally, and then terminals, they are generally represented by lowercase letters. See here it is ID or A, B, C, and also the operators plus, minus, star and then slash, all this will come under terminals. Next convention is start symbol, which is generally denoted by S, but in this grammar it is E. Whatever the first production is there, its left hand side is considered as start symbol. Next, here we are using OR symbol to separate the multiple rules applied for single non-terminal. Here for E you are having 3 rules: E plus T, E minus T and then T. These are separated using OR symbol. And then if there are any common used alpha, beta, gamma letters, they represent the string of grammar symbols. And then epsilon, if you are having epsilon in any grammar, it represents the empty string. Let us see what do you mean by a derivation. It is nothing but a process of generating a valid string from the start symbol by repeatedly applying production rules. The construction of a parse tree can be understood more clearly through a derivational view. In this approach, the production rules are treated as rewriting rules. We begin with the start symbol, and at each step a non-terminal symbol is replaced by the right hand side of one of its productions. This process continues until only one terminal symbol remains. Derivation provides a systematic way to show how a string belongs to a language defined by the grammar. This derivational view corresponds to both top-down parsing, where the parse tree is built from the root to leaves, and also the bottom-up parsing, where the parse tree is built from leaves to the root. Now let us see the types of derivations. There are two types. First one is leftmost derivation. Second one is rightmost derivation. Coming to leftmost derivation, it is a derivation in which at every step the leftmost non-terminal symbol is replaced using one of the production rules. In simple words, whenever there are multiple non-terminals in a string, we always choose the one that appears first from the left. Consider this grammar: S goes to ASB or BSA or SS or epsilon. Now let us derive this string ABAB using this grammar. We will start from this start symbol, and then you can choose any one of these productions. I am going for S goes to ASB. Okay. When I am considering ASB, as it is leftmost derivation, you have to see from the left side. When you are searching from the left side in the step, what is the first symbol you are encountering? A. It is a terminal. Next, S. What is the first non-terminal we are encountering from the left side? It is this S. Now you can replace this S in this step by any one of these productions. I have replaced this S with BSA. S goes to BSA. I have replaced with the RHS of the production. Now, again in this step, when you consider from the left side, what is the first non-terminal you are encountering? See, this is the terminal. This is the first non-terminal. You can replace with any RHS of the production. I am replacing it with S goes to epsilon. It means it is replaced with epsilon to get ABAB. This is leftmost derivation for ABAB. Coming to derivation tree for this example, see here in first step what I have done, I have replaced S with ASB. In next step, S is replaced with BSA, and then S is replaced by epsilon. This is how we can see the derivation tree, and simply what it will tell how the string is using the production rules to show the tree. Second one is rightmost derivation. You can call it as RMD. Coming to leftmost derivation, you can call it as LMD. Now, RMD of a string it starts from the start symbol S. Similar to leftmost derivation, this will also start with the start symbol S. By replacing the rightmost non-terminal, what you will do, you will replace it with the RHS of the corresponding production. See here, I am considering the same example and same string ABAB. Again, we will start with the start symbol. Here I have taken S goes to SS. If you consider this, as it is rightmost derivation, you have to see from the right side. In this step, you have two non-terminals. But which one I have to take? Whatever the first non-terminal you are able to see from the right side, that one you have to consider. If you are seeing from the right side, what is the first non-terminal encountered? This S, not this. Means I have to replace this S with any one of the productions so that I can produce ABAB. I am replacing it with ASB. Again, in this step also I am having two non-terminals, which I have to replace whatever the non-terminal you are encountering first from the right side, means this is. Here you have only This S is replaced with epsilon, means you got SAB. In this step, as you are having only one non-terminal, simply you can replace with any one of the production. It is replaced with S goes to ASB. Here also you are having only one non-terminal. If you want to get AB, I am using the production S goes to epsilon. This is how you have to do rightmost derivation. And see the tree. In first step, what we have taken, S derives SS, and in next step, last S, second S is replaced by ASB, and then this S is replaced by epsilon. Next, first S is replaced by ASB, and then this is replaced by epsilon to get the string ABAB.